Chapter 4, Section 7, Congruence in Overlapping Triangles. Identifying corresponding parts of triangles. So we need to look at this in a few different ways. We can look at it as the big overlapping triangles. So this triangle and this triangle. So we're looking at those. Well, we can see that this angle is the same angle. So by the reflexive property, it's congruent. We can also see the different corresponding parts. If the triangles are congruent, then this angle is corresponding to this angle because it's these two angles here. And then this third top angle is corresponding to this third top angle. The corresponding sides are fairly simple. We have this side, which is the base of the triangle, is corresponding to this side, which is the other base. These two sides are congruent, which are these two sides here. And the final two sides are congruent, which are these two sides here. Now we can also look at it as the smaller triangles. This triangle and this triangle. In that case, these would be corresponding, these would be corresponding, and these would be corresponding. And for the angles, this angle, and the third angle. Depending on what the given information will tell us what triangles to start with and what triangles to end with. Usually you're going to have to prove a pair of triangles congruent before you can prove the second pair of triangles congruent. So let's say that it's given that line segment AF is congruent to line segment EF. So AF is congruent to EF. Line segment FD is congruent to line segment FB. And AFB is congruent to EFD. Well, if we're looking at these two chopped triangles, we just got side, angle, side. So all of these given statements give us a side, an angle, and a side. So the two triangles are congruent by side, angle, side. Now it wants us to prove ACD congruent to ECB. Well, in order to do that, I need a few more segments and angles. So since we have these two small triangles congruent, I'm going to state by CP/CTC that angle CAD is congruent to angle CEF. And that would be by CP/CTC. Since they're in the smaller triangle as well as the bigger triangle, we can say that they're congruent. Then by the reflexive property, ACD is congruent to ECA or ECB if we're looking at the two other triangles. So now we have two angles. We know that AF is congruent to EF, and we know that FD is congruent to FB. We want to somehow put those together to get these two sides congruent so we could prove the big triangle is congruent by angle, angle, side. Well, first we have to change them to equals because congruent segments have equal measures. Then we use the segment addition postulate to state that the whole equals the sum of its parts. Now in this case, there's a few different ways you could think of it, but I use substitution. Since AF equals EF, instead of writing AF, I replaced it with an EF. And since FD equals FB, instead of writing FD, I wrote FB. So now I have that AD equals this, EB also equals that, so they must equal each other by substitution or by the transitive property. I then change the equals to congruency, and then I have the two big triangles congruent by angle, angle, side. You just have to break it apart. Look at the given statements. That gives us these small triangles. Well, using those small triangles gives us an extra angle in the bigger triangles. And then we just need this last side, which we already have some pieces of information on.